Hi everyone. Now I'll explain a case related to the audio processor. As what I said before writing the driver, we can write a function to print the debug information. And here is the debug info function for printing the debug information. Then we come to the API of the audio processor. We need to know how these products work. Here's the introduction of these products. It says it supports UDP RS-232 and also RS-485 is okay. And there are two versions of control protocol, version 1 and version 2. Version 1 is the fixed length message packet, and version 2 is the variable length message packet. Let's come to the version 1 protocol first. Version 1 protocol is a 12 bytes message packet, and we need to know the meaning of each byte. For byte 1, it doesn't explain anything about byte 1, so we don't need to pay attention on it. For byte 2, is a message type. And here it says 21 is parameter control, 22 is parameter acquisition, and 13 is switching scene. So 21 is to control, 22 is to get, and 13 is to switch scene. For byte 3, it says it doesn't affect the use, so we don't need to pay attention on the byte 3. For byte 4, here it says version 1 sends a control command of 0 and the device replies with the E0. And for byte 5 to 12 are data bytes. Here it says when the message types are 21 and 22, byte 5 to 6 are module ID. We need to see appendix 1. And byte 7 to 8 are parameter types. Here we need to see appendix B. Byte 9 to 10 are parameter value 1. Byte 11 to 12 are parameter value 2. And here it says most modules only have one valid parameter, such as controlling the compressor switch. Switch value 1 for off, 0 for on, and only need to fill in the parameter value 1. It means that if we want to control the compressor switch, we just need to fill the parameter value 1. 1 is for off, 0 for on, and parameter value 2 are all 0. Byte 11 to 12 are all 0. In the case of two parameters, there are input module, output module, equalization module, and automix module. And here it introduces about the input and output module. Parameter value 1 fill in the channel number starting from 0. Parameter value 2 fill in the parameter value such as mute. 1 is for mute, 0 for non-mute. And it gives two examples of controlling the input channel. One is for control the input block channel 1 gain step, set it to 2. And the second one is control input module channel 1 gain to -36. One is for gain step and the other is gain. Here we copy the gain step to parse the detail. and point 1 is B3, point 2 is message type, 21 is for control. So here is 21. And byte 3, it doesn't matter. Byte 4, here is that it send the command, send a control command of 0. So here is 0. And for byte 5 to 6, we need to see appendix A. The module ID assignment. We're controlling the input source, so the ID is 299. 299 is the decimal, and converted to hexadecimal is 12B. It is 012B. And here we need to put the low digits to byte 5 and the high digits to byte 6. So byte 5 to 6 are 2B and 01. Then for byte 7 to 8, here we need to see appendix B. We come to the appendix B. This is setting its gain step, so here the parameter type is A. So here it should be 0008. So here is 0A and 00. And then byte 9 to 10 is parameter value 1, and 11 to 12 is parameter value 2. These are the parameters. We are setting the gain step to 2. And here we convert C8 to hexadecimal is 200. So here, for the positive number, we need to multiply it by 100. So we need to multiply the number by 100 when writing the code. Then for negative number, we can see the value is F0, F1, but actually it is F1, F0. It is 61,936 in decimal number. Here we need to figure out how to convert the negative number to hex. We can see that this number is equals to 65,536 minus 3,600. So how can we get minus 36 to this number? Then we can get a formula. This number is equals to we can get this formula. So this formula is what we need when writing the code. And now let's come to the code. Set input volume. And I'm going to put the appendix A and appendix B on the screen. Okay. And I have set two parameters. One is input channel and the other is the volume. If you want to let the user to put number to set the input channel, they usually put 1 for input channel 1 and 2 for input channel 2. So here we need to -1 because it is start from the 0 and convert to hex. Then we need to get the length of the input channel number in hexadecimal. It is because when the value is A in hexadecimal, it will only be the A and will not be the 0A. So we need to put the 0 in front of the A. So here we need to get the length of the hex, and we need to define the high digit and the low digit of the input hex. Transform value is to multiply the volume value by 100. Is to do this action. And then convert to hexadecimal number and get the length. We need to define a variable for minus volume, and here we need to get a high digit and a low digit. So if the length of the input hex is 1, we need to add 0 in front of the input hex. So if it is 2, the high digit will be the input hex and the low digit will be 0. So we need to get the high digit and the low digit and swap their place. Else, if the length number is lower than 1 or more than 4, we'll print the input channel as invalid. And then for the volume value, this is basically the same as what we did in input. This is for the positive value, and this is for the negative value. And then put them together and send them out. This is for setting the input volume. And for getting the input volume, we use version 2 protocol. Point 1 is B3 and byte 2 is message type. Here 21 is for parameter control, 22 is parameter acquisition, and byte 3 is the length. Length is the variable length. It starts calculating from the byte 9. Byte 4 it says version 2 sends the control command as 01 and the device replies with the E1. This can be the flag to know whether we are using the version 1 or version 2, or the device replies with the version 1 or version 2. And for byte 5 to 132, there are data bytes. And here we come to the parameter acquisition. Here it says for byte 5, 1 is output, 2 is input, and 3 is reserved, and so on. And byte 6 is the starting channel number, starting at 0. And byte 7 is the end channel number, starting at 0. Byte 8 is the parameter types, as defined in Appendix B. So here, the Appendix B is what we needed. Byte 9 to 72 are parameter values. And here it gives the example of getting the input 2 to 6 channel level with the code. Here we copy it. Here we see the code. Byte 1 is B3, and byte 2 is message type, is to get the message. And byte 3 is the variable length. I've told you that it started from the byte 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, from here to the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 bytes. So here is 10 in hexadecimal number. And byte 4 is 01. Here it says it sent the control command as 01. And the device replies with E1. For byte 5, we are getting the input channel. So here is 2 for input. Byte 6 is the starting channel number. Here we are getting from channel 2 to channel 6. And the number is starting at 0. So here is from 1 to 5. And here, parameter types, we need to see the Appendix B. And here we can see the C is for the level. So here is C. And the rest parameters are all 0. And for the reply, the first 8 bytes are the same, so here we delete it. And the rest are the volume value of each channel. So here we come to the code. We need to calculate the channel number because we need to figure out the value length for byte 3 and change it to hexadecimal number. And the rest are, I think, is basically the same with setting input volume. Here, the fourth sentence is to add the 0. And the point is how to parse the feedback. Here I wrote a parsed feedback data. First, we need to check the feedback data is with version 1 or version 2. Here we use string substring to get the byte 4. If it is reply with version 1, the byte 4 will be E1. E0, I'm sorry. The byte 4 will be E0. And if it is with version 2, it will reply with E1. And here is to get the version 1's data, get the module ID and the parameter type. If it is E0, means that it replies with V1 with version 1. And we need to check the module ID. Check each module ID. And then we need to get the parameter. If it is returned with the volume value, here I wrote a feedback version 1 input slider value. If it is with version 2, I wrote the feedback version 2 input slider value. And here we come to this function. Here is to get the start ports and the end ports, then convert them to integer, and here is to get the parameter data, and here is to calculate the ports. How many ports? We need to know how many ports. And here is to parse the volume value, parse these data. And then here is to feedback the positive value, and here is for feedback the negative value. These are the mathematics issues, so I won't talk more about this. And I've created driver event for the feedback of the volume value. This is to change the input volume value. And here I set the input port and the volume. And if we need to show it on the UI, we open the slider page. And here, if we want to use this slider to show the volume value, create a device. Here we need to bind this to a driver package. Create a device. Define driver. Here, if we want to let this slider to show the volume, in driver events here, there is a change input volume event. We can click here to add actions. We can directly use the style control and individual control. The slider, choose this slider, and the value is, here we can see the volume. And that's all for the case of the audio processor.